Terrific. Well, good morning or good afternoon, depending on where you are in the world, or evening perhaps. Thank you all very much for joining us today. We're going to be talking about attack surface management, a term that has taken on some more prevalence over the last, probably 18 to 24 months. Something that if you're in the IT security world, maybe a more familiar term. If you're in the OT security world, it may be something that is just starting to hit your ears. So today's focus is on just a bit about what it is, and then how do you bring OT effectively into that model, and how can it benefit you on the OT side from a cybersecurity prioritization. And there are some significant benefits that we'll talk about today. Just by way of introduction, my name is John Livingston. I'm the CEO of Verve. I spent about 20 years of my career with McKinsey & Company, which is a global management consulting firm. And I've been with Verve for a little over 5 years. Just for context of who we are and how we come at this question of attack surface management. So Verve was founded approximately 30 years ago. We were founded as a control systems integrator. So think of helping to design control systems across a range of different industries: power, water, chemicals, steel, paper, et cetera. And then with the introduction of NERC-CIP here in North America, which is the cybersecurity regulations broadly, cybersecurity, reliability, et cetera, regulations on the North American power grid, our clients turn to us to help them secure and meet those compliance requirements. And so we built the first version of what we call the Verve Security Center back about 15 years ago. And we've been working with clients ever since, helping them both use the platform to improve their security, as well as providing a range of security services that go along with that to help them prioritize, et cetera. And this attack surface management is very relevant to this, because a lot of what we do with the platform and frankly with our services is to help clients prioritize. As those of you who are in OT security know, when you first start the journey, it's a bit overwhelming because of the number of things that you could possibly go fix. And what we'll talk about today is how attack surface management helps you prioritize all of those things that you could possibly go try and solve. Anyway, that's the quick introduction of myself and Verve, and we'll dive in here. So first, we're going to spend a few minutes talking about what this is. What is attack surface management? Why is it relevant for OT, et cetera? By the way, for those of you who may not have been on prior webinars, just to make sure we're on the same page, OT is operational technology. So these are the control systems that the IT type systems that control physical processes. So everything from making oil, making power, making pharmaceuticals, all the way to controlling heart monitors in a hospital or building controls. The second topic we're going to talk about is what are the challenges of doing ASM in an OT environment? Why is it kind of problematic, and why do people struggle with it? And then lastly, we're going to talk through a little bit of the key steps of how do you do this, and what's our approach to doing it, so you can see a little bit of kind of case studies about how you go about this. So first, the definition. What is this thing we call attack surface management? So this is based on a variety of sources trying to get to one simple definition. So it's the continuous discovery, collection, assessment, classification, prioritization, remediation, and monitoring of all of your T technology assets: IT, OT, IoT, et cetera. And we'll talk about those pieces of discovery, collection, assessment, et cetera. Some people will think of this, oh, well, that's vulnerability management. But it is different in that it takes essentially the attacker view of the challenge, meaning it helps to prioritize what of all of those vulnerabilities and risks are critical and which need to be addressed first. When done correctly, it allows an organization to prioritize their most critical exposures. Importantly, when we think about vulnerability management, not that it has to be defined this way, but most people tend to think of it as looking for known CVEs, meaning known common vulnerabilities. But the true risk is much broader than that, right? It includes insecure access. It includes software that shouldn't be on a system. It includes configuration settings that are inappropriate, even though they're not quote unquote a vulnerability, they could be inappropriate and could be hardened. It includes lack of certain security controls. It might include firewalls that are not locked down. Essentially a whole set of things that's more holistic than just the CVE. So again, continuous discovery, collection, assessment, classification, prioritization, and remediation, and monitoring of these assets. So there are really 6 key elements in that. The first is discovery. So can I see, quote unquote, all the corners of the world of the attack surface? And this includes unknown assets. So this is particularly prevalent in OT, right? We've got oftentimes many unknown assets. Unknown connectivity, meaning we have 2 systems, but we don't know that they actually talk to one another. The software on those systems, the configurations, the users, the accounts, et cetera. So discovering the full attack surface. The second step then is assessing it. So identifying what is the risk of an asset based on what we refer to as a 360-degree assessment, meaning seeing all of the risks, not just the vulnerabilities, but all of those different risks I talked about. Third is context then. So it's great to know that that asset has risks, but how important is that asset and where does that asset sit within the overall architecture? So within an OT environment, a lot of this comes down to what's the criticality of that device? What is it used for? Potentially who owns it? So that we can create a risk profile of that asset from an attacker's perspective. In other words, how attractive is that from an attacker's point of view? Fourth, then, is prioritization. So this is where ASM starts to differ from vulnerability or inventory management, because it's starting to prioritize those risks, all of those various risks, based on where an attacker, A, couldn't most quickly get in, and B, can do the most damage. And eventually that allows us to create a risk score for those assets or for those vulnerabilities and risks that we can then take a prioritized set of actions. The next step is obviously to fix it, so remediation. And that's not just a one-time thing, it's a consistent hardening of security directed by that prioritization we just talked about. And then finally, the hardest part of all of this, which is, okay, now I've done this, how do I maintain it? And it's ongoing updating, regularly reviewing new threat vectors to identify new risks as they emerge. Part of this is threat intel, but even more important than threat intel is the changing of the assets themselves. As we all know, if we're not paying attention, configurations can get changed, software can get deployed. And so there's a significant amount of maintenance that goes into effective ASM. So those are the key steps of broadly what's defined as ASM. So now, why is it relevant in OT? Well, OT until maybe a couple of years ago, we talked about a lot of threats, and it was growing, don't get me wrong. But the last 24 months or so has been quite an explosion in the level of attack, and frankly, the responses from organizations' leadership about those attacks. So the number of attacks have gone up. Mostly what we see is this is tied into ransomware. There's a significant increase in people's understanding of the profitability of ransoming an industrial system. IT is moved more and more into the OT environment. And we're now at a point where it's quite prevalent, and therefore the risks of IT move over into OT. that is causing a bunch of things to happen. So number one, regulatory pressures increasing on an ongoing basis, resource constraints. So as more of these vulnerabilities get exposed, there's just not enough bodies to solve the problem. More and more remote access, particularly during the COVID period, where it was going up by 40-50% a year. Insurers now are requiring a much greater element of proof of your OT security to be able to gain cybersecurity for those manufacturing your industrial assets. And as a result of that, directors are now stepping in, boards of directors, and demanding more. So there's just a ton of focus, both by attackers, external parties like regulators, internal parties like boards of directors, that drive us to needing a way to address these risks. And ASM is a practical way of doing that. So it's just a couple of points to back up this growth. So from the SANS ICS survey, right, essentially almost a tripling, 2.5x of the people who think that the risks of cybersecurity OT are severe. And then, as you see on the right-hand side, ransomware, which was basically nowhere. It wasn't even on the top 5 list of the greatest threat vectors 2 years ago. In the 2021 survey, it was over 50%. So there's just a significant shift in the way people are considering the risk of these environments. Not surprisingly, given the number of vulnerabilities. So this is our analysis from all the ICS advisories over the past few years. And, starting in 2019, then 2019 to 2020, we had about a 30% increase in the number of advisories. Well, then we had another 30% increase, which is obviously a bigger number in 2021. And in 2022, we're on pace for that same kind of thing throughout the first half of the year. Similarly, the number of CVEs has increased by roughly 40% a year. And these are not, little things not worth worrying about, right? These are almost on average, it's almost a critical CVSS score. So CVSS is a 1 to 10 score. And the higher 8, 9, and 10 are the critical ones. And so we're almost at critical on average. And that's increased as well. So as we think about those risks, they really do move from the IT world into the OT world, right? So OT is no longer just an air gap system out there that can't be hit. The entities can implant ransomware, using common methods. They gain access to the enterprise systems. They then exploit vulnerabilities, and then they can traverse the networks, right? And the first big one of these was NotPetya WannaCry, but this works very similarly in a lot of the ransomware, where they can get through weak ACLs if there is a firewall. Many organizations don't even have firewalls. They may have routers between their IT and OT networks. Oftentimes we have shared accounts between the two, or dormant users that they could pick up from credentials from the dark web, et cetera. Then they get into OT, and then in most cases, because there isn't an aggressive ASM type program in OT, you've got a lack of control. So it spreads through OT pretty quickly, and then we don't have typically backups tested, ready to go, et cetera. So it's a pretty significant threat as these IT threats now start to target that move over into OT. One recent data point, which sort of screams at the need for this ASM in OT, is a recent survey done by KPMG and the CISA group, which is an industry association. And what you see is the percentage of devices that are accessible, OT devices, that are accessible from the internet, from a business network, or remotely. And I mean, this is, in somewhat astonishing, right? So how many of these servers or workstations or historians are actually accessible from the internet? Now, there may be very valid reasons for this. There may not be. But the point is that when we think about the attack surface, if we don't understand exactly what's being connected to these different external. By external, I mean external to OT. We've now just expanded our attack surface, the number of ways that someone can get into our network. And we see this all the time. We do regularly, we're doing assessments with clients using our platform. And we see this all the time, right? That there's devices that are hanging off a network that is connected into the internet because some vendor needs to access that system. No one really, I mean, people kind of knew it, but it wasn't documented anywhere. And so as you go in, you start to see these flows, you start to see firewall rules, you start to see dual NIC devices, and the attack surface starts to explode because you see all of the potential ways for attack. So this is just, one data point that reemphasizes the importance of ASM. And when we ask people, and this was from a group called Chimru, when they asked in 2021, what is the limitations of the ASM platforms that are currently out there? The number 3 reason was a lack of visibility to those technologies like OT and IoT. So that, as we think about what are the problems that people are dealing with in ASM, one of the big ones is, all right, how am I going to get a really clear visibility to things like OT? So that sort of gives a brief definition of what ASM is and why we believe, anyway, it's very relevant for OT. So what are the challenges, though? So why isn't everybody just doing this? Besides the fact that it may be that it's not in people's awarenesses yet, but there are very specific challenges to pulling this off in OT. So the first is just the discovery. So for those of you who have tried this, right, these complex network architectures, devices sit inside a rack, they sit behind natted firewalls, unmanaged switches. And so, and misconfigured network devices often create potential flows, even if none are currently occurring. And all the detailed data like software, users, configurations are difficult to capture unless you're capturing them directly from an asset, right? It's really difficult to do this if all you're doing is monitoring network traffic. The second piece is the assessment then. So it's difficult to see, again, that 360-degree risk if all you're doing is relying on monitoring of flows or monitoring packets. You really have to get into the weeds of that asset to get the information out. On the context front, what we often find is operators don't have a well-defined asset criticality prioritization. And we need some way to apply that simply to provide a contextual overlay of the usage and the criticality of an asset. And then obviously, if you don't have those things, prioritizing greatest risks is often difficult. We all know, if we've been in OT, remediation is a big challenge. Technically, it's a challenge, meaning like what tools are we going to use? But then also, how do we manage fixing, patching something, let's say, or changing a network configuration when we have plants that are running 24/7. We risk possibly disrupting operations if we try to upgrade the firmware of a PLC. And so the remediation and the prioritization of that becomes challenging. And then finally, we talked about the resources problem. Resources is a real challenge if we want to maintain this. So, okay, this means doing this effectively in OT requires, some special sauce, so to speak, to make it work. Just to sort of highlight those points around why it's challenging, right? OT is different. For those of you who are coming at this from the IT side, right? So legacy equipment is not going to support your modern IT tools, right? You're not going to run, a Nessus scan on your PLC network without stopping the plant, probably, or at least bricking a few of those PLCs. You can't, do traditional, spray and pray patching on a control system. So a range of limitations on how you're going to support security in this environment. And then the types of assets, they're not Windows. So oftentimes you can't put the traditional IT tools on them. They're older and they're running tons and tons and tons, hundreds of different protocols. And so, just saying, oh, now I'm going to take my ASM tool from IT and plug it into OT, it just doesn't work. And so what's happened is many people have started to rely on network-based asset detection, meaning tools that will go in, sit on a span port, grab data from a tap, and try to interpret the risks from those packets. And these are incredibly limited if we want to really do ASM, because I may know that device is a Windows box because if I can see the traffic, if you have a span port, we can come back to that. But that traffic, that packet doesn't include detailed patch levels. It may include like the OS version, but that's not the patch levels. It won't include the configuration policies. It won't include the users that are on that box or all of the applications. It certainly won't include the quote unquote purpose of that box. Secondly, that tells you the current flow, but it won't tell you the actual rule sets that might allow a flow. Meaning, okay, so great, I know that this is not talking to that today, but I don't know if there's not a rule that stops that from happening. Oftentimes we can't see multiple layers down when we use network traffic because we've got unmanaged switches, that network traffic doesn't come back up to the top. And so we've got devices connected behind the backplane of a PLC or controller. So we miss devices. And all of this assumes that we're going to spend the money on spans and taps and all the rest. And so again, these kinds of approaches make it pretty difficult to go after this. And then how do we prioritize, right? This is somewhat minimal in terms of the kinds of things that one would typically see, right? Shared passwords, dormant accounts, older, operating systems. Many control systems are designed with dual home NICs that are literally designed in. We've got NAT routers sharing IP ranges, tons of unapproved patches. Even if we were going to patch all of the approved patches, the vendors don't approve a bunch of those patches. So the whole prioritization question becomes challenging unless I really can get into the weeds of each of those assets to understand how I can best secure them. And then, as I mentioned, right, the resourcing problem. So this is from that same CISA survey. And what you see is that insufficient cyber control system cyber expertise and insufficient personnel are still the biggest two problems that exist within OT security. And so trying to maintain any level of ASM is challenging unless you have technology that can do that for you. It's really difficult if we're going to have to put bodies against this. So that's what ASM is and why it's relevant, but there are challenges to this. So how do we do it, right? What's an approach that actually we've seen work? So that's the next half hour or so we're going to spend talking about how to actually make it happen and overcome these challenges. And then we'll certainly leave some time for questions at the end. And by the way, if you do have questions, there's a Q&A box at the top. Just please drop a message in the Q&A. So we've talked about those 6 elements. I'm not going to repeat them here. We'll be, by the way, sending out this document afterwards, so you'll have a chance to see it. But just to reinforce, okay, we now have to deliver on those 6 things we talked about. So the first thing we're mentioning is visibility, right? So I've got to be able to, back to this page, discover. I've got to have visibility into those corners of the world. Okay, so how do I do that? The first thing is endpoint and network visibility. We need to get an accurate asset inventory of those OT devices. We need to have accurate software firmware inventory. It does us no good if we have an estimate of what we think that firmware might be. I'm just guessing at that point. I need to know certainty what that firmware is. I need to know connectivity flows and the rules that allow for the flows. I need to know physical port connections, users and accounts. This is one thing we see all the time. You may be fully patched, but you've got a bunch of dormant users on there from the last time the vendor was there doing an outage and an upgrade. And you have no idea where those user passwords are on the dark web, et cetera. And so that endpoint and network visibility allows us to do all the things we're about to start with: assess the risks, avoid false starts where you've started down some remediation path, like network segmentation, and you're stuck because you don't even know what you're trying to segment. We see this all the time. So anyway, this is the starting point. And so you have to get down, and we think about this in the way of, if you were fishing, well, if I'm using, a network traffic approach, I'm only seeing, the top of the water there, but all the fish are down at the bottom. And so we want to be able to get all the way down to those through the back plane. So if I've got a PLC, I want to go through that back plane. I want to know the ENBT cards. I want to know devices that are connected to that back plane. I need to know those network devices that I mentioned before. So what are the rule sets? What is allowed? What's not allowed? Obviously, vulnerabilities, patch statuses, password settings, etc. That full view of the asset allows me to do the next set of steps we're going to talk about. So there are a lot of myths when it comes to conducting OT safe asset discovery. And a lot of these are perpetuated by some of the OEMs who, well, I won't talk about reasons why, but these are myths that are perpetuated by a range of different groups that are just fundamentally not true if you do it the right way. So number one, network traffic is going to gather you enough. We've talked about that. There's just a ton of gaps with using packets. Second, using some form of a software agent isn't safe. The reality is they can be deployed safely if they're designed specifically for OT and they're tested with the various control systems over time. That doesn't mean you want to throw on any Windows agent that you find. Point is, you can design OT safe agents. There's software that runs on these systems all the time, as long as you do it in a way that's minimally, uses minimal CPU, no minimum traffic, tested on the control systems, et cetera. The idea that active communication devices will cause disruption, meaning if I send a particular packet to a PLC, oh, well, that's going to knock it offline. And this comes from many people's experience where they've tried to do an Nmap scan or something in OT. Yeah, that won't work. That will knock off all sorts of devices. However, operators are communicating with devices every day, right? They're logging into a controller, they're reprogramming, they're sending new ladder logic to a PLC, et cetera. Okay. Well, how are they doing that? They're doing that using the protocols designed by the OEMs to interface with those systems, the administrative protocols. So by using those same administrative protocols, we can do very safe, very deep asset discovery. And finally, the point about flows and packets are enough to understand the network architecture. Again, we're going to harp on this a lot. We need to understand potential traffic, not just current. So these myths have created almost more barriers to doing this than are necessary. And so, and we've been doing this, as I mentioned, been in business for 30 years dealing with these control systems. And so we've learned that we have to question some of these myths if we're going to get ASM to work effectively. So once we've gotten, and we'll talk more about how do we do that discovery, but once we've discovered those assets and we've understood what they are, we then need to look across a comprehensive risk assessment. Now, this is a framework from DHS here in the United States, but it's the defense in depth kind of framework, right? And look, there is no perfect framework for this. We're just trying to use something that's simple. Obviously, policies and procedures are a big part of any security program. And so understanding those things is important. But when it comes down to the ASM, we start to get into the technical specificity around perimeter network. Do I have, how robust is that perimeter network? Do I have, as I mentioned before, devices connecting directly to the internet? Remote access coming in from vendors that isn't protected through the perimeter network. Then within that, I've got an OT or ICS network possibly. How secure is that, right? Do I have real separation between IT and OT? And do I have robust segmentation within the OT environment, or do I have dual NICs that are routing around that? Somebody asked the question before this session, sent in a question before about, but there's always these patch servers or servers that you're using to update antivirus. And but there are ways to architect those such that you can protect them using things, proxies, et cetera, where you can protect those with additional layers of security. So you're not just, opening up the system. We can talk more about that in the Q&A. Access control, looking at default passwords, that's a big one. We always find devices with default passwords. And then finally, at the endpoint level, patching, inventory itself, malware protections. Are they deployed? Are they not deployed? We often find a lot of risky, quote unquote, software, TeamViewer and other things that don't really need to be on there. So what ASM requires is this comprehensive risk management, looking at each of these layers. And we mentioned this up front. It requires what we refer to as this 360-degree view of risk. So it starts with the inventory, right? You can't do anything without knowing what the asset is. But then as we dive in, being able to pull the software out so we know what are the vulnerabilities in that environment. So on that asset, knowing all the software, the patch statuses, et cetera, we can then define what are the publicly known vulnerabilities. I can look at missing patches. I can look at insecure configs, users' accounts. I can look at, is that device protected from a network protection point of view? Does it have a backup? And is that backup, recent? Finally, then what is the criticality of that? And by looking across those, I can start to get into the ability to prioritize, right? Because I can assess using that full picture. So often, really, when you think about what ASM has done in the IT world, a lot of it has been gathering data from a bunch of different tools, right? So I used, Tenable for vulnerability management, and I use SCCM for patching, and I use Tripwire for configuration management, and I have some, PAM, CyberArk or whatever for user and account, or maybe I'm using Active Directory, and I've got, McAfee for my malware, and I'm using Cisco and Cisco ISE for network, and those, Veeam for backups. And so what they're trying to do is pull this patchwork of data together to tell a story. And what we're saying in OT is, in most cases, companies, organizations don't have a lot of those things already in place. And so what we argue for is, well, then don't create the silos. Use something that brings all that together day one, rather than building silos. Or if there are existing software in place, great, let's just integrate that. And we'll talk more about that platform. The point is, we have to get all this data in one database so we can start to make trade-offs. Obviously, CVEs are the starting point, right? Whenever we do what we call a tech-enabled assessment with our clients, the CVEs just pop out, right? You're seeing these vulnerabilities, and you can look at those vulnerabilities by type of device, right? By servers, networking, embedded PLC type things. We can look at those vulnerabilities by their type of exposure, whether that be availability, integrity, confidentiality. And then you can get into the weeds of the specific vulnerabilities on each asset to be able to score them, right? But again, we're going to talk about this. That's just one lens on this problem. So it's great. I now know where the vulnerabilities are. And a vulnerability management tool, that's kind of what you're going to get. The second piece then is looking at configurations. So risks can come from misconfigured devices. And there's a range of standards, CIS, others. We at Verve have our own specific one for OT environments. And then we can look on each asset against what are those security settings within the configuration, and are they actually secure or not? This again gives us another lens on that overall attack surface. Similarly, access control. So bringing in, in that 360-degree view, bringing in the account picture. So do I have a bunch of admin accounts with expired or default passwords? Do I have a bunch of inactive accounts which could be used by somebody to come into the system and engage that inactive account? Do I have administrator accounts that were set up by a vendor or something that still exists that I need to clean up? So again, it's another attack vector, attack surface that an attacker could use. And then obviously being able to see the network risks. So, do I have remote access coming in from various places? Do I actually have VLAN separation if I'm using VLANs, or do I have hardware separation? Do I have dual homes, et cetera, right? The point is that bringing in that network picture adds another layer of that 360-degree view. And then finally, this idea of establishing criticality. So adding context to those risks is absolutely critical, right? So I want to understand, where are the safety systems? Does this device have control over critical processes? Does it provide me access into other parts of the network? What's the presence of critical programming software on that device? Are these network devices that are necessary so that the operations can continue communicating? And then what we do is we'll take that asset type, we'll look for those criticality components, we'll look for the risk components, like is it patched, is it not? That gives us a unmitigated score. And then we add in things like compensating controls. So, okay, that may be unpatched, but you've got application whitelisting, and that application whitelisting is in lockdown mode, let's say. Okay, that's going to reduce my risk score than just a completely unpatched system. And then you get a residual risk score, which combines this asset criticality with the risk. And we're not, obviously, we don't have time to go through this whole math today, but the notion is to be able to take that 360 view and add context to it. So I'm starting to get risk and criticality in the same metric. And that's going to start to allow me to do that prioritization. And so this is just an example of how, as somebody uses a platform like ours, you can then say, okay, these are all my assets, but then I can really focus in on which are the assets with the largest impact and which are those with the greatest risks. And so we can calculate a number that brings all of these different elements together to provide insight into where to focus. And that's back to the whole point of ASM. It's all about prioritization. It's all about enabling you to take all of those inputs and start to prioritize where to point the gun. So as an example here, and this is a lot of stuff on a page, so we've tried to blow it up a little bit, right? What you might find is, okay, the first thing we're going to do is look at those CVEs, and we're going to see, wow, okay, we've got still remaining WannaCry, NotPetya, unpatched systems. So in other words, we didn't patch the SMB vulnerability in those systems. Okay, we probably want to start there, given the exploitability of that. We also, in our case, we integrate with all the CISA known exploits. And so we can add in a bunch of context there. But the point is, focus on those with a high level of exploits. And then we can drill down to critical vulnerabilities. Further, we can drill down to assets that do not have some form of a compensating control. In this case, no application whitelisting. We can then focus down on those that are critical assets, meaning they are critical to operations. And so we can go from a world where you've got 30,000 vulnerabilities to a focus of 300, right? Where we say, okay, those are the critical vulnerabilities on critical assets where you've got no application whitelisting and it's not in lockdown, and you've got no backups. Okay, those are really at risk to attack, or better phrase, to impact. And so I really want to go after protecting and patching those systems as quickly as I can. That's just one example. I'm just using that as an example. The point is to be able to drill down using that 360 view to prioritize against that attack surface. And so what that then allows us to do, once we have the 360 view, we can model attack paths, right? We can say, all right, so an HMI or controller is exposed to external access. So there's some unknown rule that nobody knew about in the OT firewall, right? Well, then I'm going to get that attacker could come in, and I've got dual NICs. So they get in through that firewall, and I have internal firewalls, but I have NICs that dual nicks that allow that attack to spread around the VLANs or around those firewalls inside the plant. Then once they get there, I've got dormant account on that next HMI with credentials that allow somebody to take control of that HMI. And then I move through unpatched but approved SMB vulnerabilities, meaning I didn't patch that WannaCry, and now I'm using SMB to move forward. And then I've got a lack of backups, right? But this is just one example. We can model these various attacks once we have that, that insight from the 360-degree view of the risks. And then that allows us to start to prioritize actions. So the third step in our process, right, or fourth step, sorry, is to prioritize actions. So leverage my current capabilities to mitigate those immediate threats. Great, okay, I can go immediately get rid of those dual nicks. I can reconfigure those firewall rules that were open to tighten down those rules. I can harden my network configuration compliance. So Cisco, let's say, has a set of hardened compliance standards, and that can allow people in if it's not hardened. Great, I'll lock those down. And I could go through all these. The point is that we want to lay out that prioritized set of actions based on the risk and those attack paths that allow us to really get down to what is the most critical set of things to do. And this is just essentially a visual demonstration of that. I won't go through it all here today. Again, you can have the presentation, but basically to try to prioritize things that are risk reduction. So things that I do to reduce the amount of risk, like patching, versus things that I'm going to do for threat response. So for instance, on an ICS or an OT server, I may deploy and monitor canary files, right? And those canary files allow me to see when ransomware is hitting that device. And then again, on the prioritization thing, this is one of the things that we often do with Verve is we'll take all of those patches that are required, and then we'll do essentially an 80-20 on patch application, because patching is so challenging. What we try and do is to say, okay, if I deploy this patch, so the Jan cumulative, in this particular example, right, it knocks off 10% of all of the CVEs in that environment. And I can go through here and I can say, okay, if I just deploy 7 patches, I get, 70% or whatever the number is of the CVs. And I can, we could do this prioritized even more than that around, I'm going to focus on just critical CVs. I'm going to focus on critical CVs on critical devices, right? But you get the gist. Because all of this data in an ASM platform is together, I can then prioritize these based on all sorts of ways that I need to. The next step is to remediate. Right, step 5 is to actually go fix this stuff. So I've done the 360 risk assessment, and now I need to move to remediate. One of the keys to this, at least in our mind, is that we don't separate the assessment from the remediation. A lot of times, attack surface management is thought of as it stops at the assessment and prioritization phase. And then because IT has all of these tools that they've put in over time, it then gets handed off, maybe it goes to a ServiceNow ticket, and then it gets handed to the patching team, or gets handed to the network configuration team, or gets handed to the configuration management team, et cetera. Our view in OT is we don't have the resources to be dealing with, okay, we're now going to have 6 different teams trying to do the remediation. So having the ASM platform actually enable remediation is critical. So let's, in our case, we enable you to patch, to harden configs, to remove risky software that's on the system, remove unnecessary users and accounts, change passwords, all of those different things that we want to do. Now, obviously, there'll be some things that will require, manual service efforts, like redesigning a network architecture, right? You can't put in a firewall with software, but you can create essentially alert-based firewalls, meaning monitor traffic between devices, and if it ever communicates, you send an alert. So there are some things you can do with software, but you may need to eventually get to actually manual efforts to do things like network segmentation. But the point is to be able to bring the remediation and the assessment together so that we can accelerate the move from, okay, I found the priority, now I'm going to fix it. And I can continue to maintain that over time. And then, as I said, maintain it over time, right? Be able to monitor, how am I doing against those critical vulnerabilities? How am I doing, literally day by day on, am I patching them? Oh, new vulnerabilities came out, that goes up. And being able to essentially have a burn down against how I'm doing against those critical risk elements. So that's the basic gist of how we think about ASM and how to apply it. And so the way Verve does this specifically is we use our OT ASM platform to make this happen. That starts with asset inventory. It starts with that foundational element of seeing all those assets. And as I mentioned before, our approach is not to use network traffic to try to do this. Our approach is to get to the endpoint, right? To use an OT safe designed agent to communicate with those devices in their administrative protocols to be able to gather direct information back. And that then allows us to do this 360 view, to see vulnerabilities, patches, configurations, et cetera, as well as to do real-time monitoring of intrusions and to be able to bring all that together into incident response. So our view is that, the only way to do this is you have to get to the endpoint to do the appropriate discovery. You have to bring all this data together into that 360 risk view. We then have to be able to remediate this stuff. So when we say patch management, to actually deploy the patch, obviously it's got to be vendor agnostic. And then what we talk about is to have what we call a think global, act local approach to this. So one of the big concerns in OT security is, okay, great, I'm going to, have this at a plant. And somebody at the plant has now got to figure out, how do I do all this prioritization? And our view is that's not going to scale. We can't do that. So we got to bring all of this data centrally from all of the plant sites, whatever is your environment, so that you have a single database across the entire environment to do that analysis. That's what we call think global. And then when you're going to take an action to remediate something, you want to make sure that happens as quote unquote local as possible, i.e., where those control system engineers are that know that control system. So you're not, sending a configuration change from 10,000 miles away at a time when the plant is in operation on a critical system. And so the benefits that we see to this approach, number one, on asset-based discovery using that OT safe endpoint approach provides just a much deeper view to the discovery. Number two, that 360 view allows us to do a better assessment. Number three, we can import a client's criticality data, or we can actually use the data in the platform to provide context about criticality. It allows us to prioritize across all those risks, as we've sort of talked about here today. And then it allows us to fix it, right? So we can actually take those actions directly from the platform. And then finally, from a maintenance point of view, this think global, act local notion allows us to get about a 70% lower cost than alternatives if you're going to be maintaining this ASM over time. So, and just a quick description of how that think global works is, so we're going to bring all that data up from the plant to a scaled analysis center, right? You could do it in a SOC, you could do it as a central OT team. You can think about a lot of different ways to do it, but having 2 or 3 people doing that, not one per plant. But then when we go to take those remediating actions, they can be distributed to the plants, but then somebody at that plant, or it may not be at a plant, it may be at a control center, whatever, but somebody who's familiar with those control systems, the schedules, et cetera, then pulls the trigger to deploy that action. And this allows us to be scaled, but also OT safe in that process. So our view of, okay, how do you get started on ASM? Where do you begin? So we think about starting with what we call a tech-enabled assessment. So getting clear on what is your framework, what are your objectives, what are you trying to achieve? Then deploying technology to get that site level risks, to be able to see those various 360 risks, et cetera, and then to do the prioritized roadmap. Look at those different attack paths, prioritize based on the 360 view, build a specific roadmap that we talked about before so that you have a game plan. And then obviously this is the assessment phase. You'd move into the remediation and maintain phases. But this allows you to get started with ASM in a way that is practical, right? You do it for 1, 2, 3 sites. Secondly, you learn how ASM will be relevant in your environment, and then you can roll that out more broadly over time. So with that, I'm going to draw us to a close. I think we had some questions before we started. It looks like there's a couple of questions in the Q&A as well. So one of the questions that was asked before, and I'll come back to the Q&As here, was, does ASM take into account non-network devices? So I assume by that we mean non-network, meaning servers, workstations, et cetera. It absolutely does. It has to, right? That is one of the key ways that people can move around, and both to various parts of the network, but also those are the places where they're going to disrupt operations. If by non-network we mean islanded, meaning a device that's not connected at all to the network, the way we think about ASM in that case is we want to make sure that that device doesn't actually connect to the network. Obviously, if we also certainly want to look at whether a vendor is coming in to connect to that device from time to time, and is that vendor's system protected when it comes in the plant to connect. That's also certainly part of your attack surface. But we also want to make sure that there's no temporary connections that get set up, for instance, for somebody to do remote tuning of that. We talked about virus definitions. Someone asked, can this platform, can Verve be used for IT as well as OT? Yes, there's nothing that stops Verve from being deployed on an IT system as well. It's just that because of the way we've tuned it, it's very, very relevant for the OT environment, but it works perfectly fine in IT as well. Karen asks, tools to add and maintain the asset list. Well, we wouldn't be here if we didn't recommend Verve to add assets in. One of the things that we see a lot is customers will use Verve and then send that data to ServiceNow, for instance, because they've got ServiceNow acting as their CMDB for IT. And that happens a lot. We have what's called a service graph connector, which allows us to simply integrate with ServiceNow. And so a lot of people will use that to maintain a corporate level of the asset lists. I will just reinforce our strong opinion. And this is obviously, look, we have a software product, but the reason we built the software product was because we were a control systems engineer without a software product 15 years ago. And we were asked by customers to solve this problem. And we tried network, we tried all these different things. And we found this to be the only way that you can really get that asset list and to maintain it appropriately. Michael asks, how many protocols do we support? Hundreds. We're pretty much communicating with almost all of the OT type endpoints that are out there. And we'll always find, when we go and deploy, we'll always find 5%, 10% of the devices that we don't have a quote unquote driver for. And it takes us a week to 2 to build a new driver if that's the case. So it's pretty robust. We've been doing this for 15 years or so. One of the questions, how do you bring context to the vulnerabilities that drive the nuance in the attack surface? So we've talked a little bit about that today. So context, if we think about it in the way that it's defined by ASM, is the criticality, meaning how important is that asset? What does it do in your process? So the first way we do that is we ask an organization, do you have lists that you've already created? So many organizations have robust asset criticality scores. Great, we'll import those. But some don't, right? They've never thought about this before. And so in that case, what we use is the data from the systems to tell us, okay, so that's a domain controller. That's the Ovation HMI. These are the Triconic safety system controllers, et cetera. And so by doing that, by knowing what these systems are, we can build the criticality. And then secondly, if context by context, we meant the how risky is it, we'll then look at that 360 view of how risky that particular attack path might be. One of the questions was around MITRE ICS framework. So MITRE ICS framework, or MITRE attack framework on the IT side, is really about two things. If you go back, if you really tighten down to what it was designed for, it was designed more for incident response, to take an attack that has happened and work back through the attack to understand how it happened. That is what it was really designed for. Now, it is used also in a step ahead of that, which is for detections, right? So in a lot of our detections within Verve and our threat detection platform, we tie those detections back to the MITRE attack framework. So a customer that uses MITRE attack can see, okay, that attack ties here into the framework, so that I can then put together where that next attack path might go. And so that is, in our view, how the ICS or MITRE attack frameworks would work here, is those would provide you with the fodder, as it were, or the baseline maybe, or the different attack paths you might want to look at. So if we see a set of risks, we might be able to work backwards from MITRE to say, okay, here would be the various steps in a kill chain that you might want to follow. I will say that is quite a challenging way to go at this, because there are literally millions of combinations that you could use. And so most organizations, and us too, when we're thinking about attack surface management, are doing that around a smaller subset of attack paths that start at the top of the attack surface and work their way down, rather than trying to tie every attack back to a MITRE. Literally, you'd be in a linear program for a long time, I think. And then there's a question, which is the best checklist for implementing best practices? So in OT security, we're really not talking about checklists today, but we find that it's not really a checklist, but starting with NIST CSF is the best place to begin, NIST cybersecurity framework. It's more high level, but most organizations, when they start, need to begin someplace. And so that's our recommendation. If you're going to start somewhere, start with the CSF. I think there's a bunch more questions that we probably don't have time to get to that were submitted before, but we appreciate your coming today. We will be sending out a copy of the presentation as well as the webinar, and we look forward to welcoming you on future webinars. Thank you so much for your time. Appreciate it, and have a great day, everyone.